Well, I'm very pleased to be speaking to you about the Mining Remediation Authority's waste heat programme. That's extracting heat from our mine water treatment schemes. And I'd just like to call out my co-workers in the waste heat team, John, Stuart, Malcolm, and Colin. And also thank Tim Vincent for the flowchart graphics I'll be showing later. So the Mining Remediation Authority, which I'll refer to as MRA going forward, manages environmental risk to aquifers and surface waters from rising mine water. And over the last 30 years, due to climate change and mine water rebound, there's been an increasing number of schemes built to sustain the demand. And these schemes provide an excellent source of waste mine water heat, generally between 10 to 20 degrees, and provides one of the most efficient low carbon sources of waste heat. And as you can see on the right, on the map, there's this huge waste heat and indeed subsurface mine water energy potential across the UK. Draw your attention to the central Scottish belt, to northeast England, to the Midlands, and to South Wales, and also call out the location of Dordon and Seaham in the northeast of England, and Lindsey in South Wales I'll be talking about later. So in this presentation, we'll be reviewing heat exchange considerations, update on our waste heat schemes in operation and those under construction, present a process flowchart for how to connect to waste heat from our mine water treatment schemes, and finish with a look at some new GIS data that we've made open source to track waste heat potential across the UK. So a few comments about some heat exchanger field trials which underpin the waste mine water heat program. So something over 15 years ago, we started experimenting with plate and shell and tube heat exchangers at our Dordon mine water treatment scheme. There was a performance reduction because they were placed on the aerated side of the treatment process and with ochre fouling, you can see on the right, and that required regular flushing and strip down. So the shell and tube heat exchanger was moved to the non-aerated or raw side of the treatment process. That performed well over the 8 years of the trial with no flushing or strip down required. Elsewhere, at the Cap House mine water treatment scheme, we trialled energy blade type heat exchangers in our primary lagoon for the treatment centre. They performed well, but there was a reduction in performance due to ochre buildup within the lagoon. We then installed our first operational waste mine water heat scheme at the Dordon plant. That's been running continuously for 5 years with no maintenance or flushing requirements. It uses a Thermex shell and tube heat exchanger, accessing a flow rate of mine water of 1 litre per second. Mine water temperature is approximately 23 degrees, and the temperature captured, or delta T, is about 3.5 degrees. There's one heat pump rated at 16 kilowatts, and that provides heat for 18 radiators and hot water. And there's a COP, or coefficient of performance, very healthy one. In winter 4.6, and the annual average is 4.2. Turning now to the Lindsey mine water treatment scheme in South Wales, we're really pleased to have completed installing an energy blade system in partnership with Thermal Earth. Turning to the graphic here, you'll see that mine water is pumped from surface and flows into a settlement lagoon where ochre precipitates. The mine water continues through reed beds where it's cleaned and filtered before discharge to the local watercourse. And Thermal Earth has installed energy blades in our lagoon, and that's taking waste mine water heat to their premises and plant room. You'll see at the bottom section that we've learned from our field trials, and to avoid any drop-off in performance, As the energy blades were lowered into the lagoons, they were mounted on legs to prevent ochre buildup on the plates. Here we've installed two 15 kilowatt multi-energy blade units into the lagoon, accessing mine water flow of 10 litres a second, 14.5-degree mine water, and a delta T of approximately 4 degrees. That gives a very healthy COP for the first month of operation for the scheme. Turning to CM Garden Village, which is a large waste mine water heat project under construction. We're really pleased that's powering ahead. And that draws on the field trials that we talked about at the Dordon Mine Water Treatment Scheme, and is now building a large heat network, something over 1 kilometre in length, to the final development when completed. And we anticipate that will be by autumn this year. The bottom, you can see the pipework connections to the energy centre, the flow and return flow lines which connect to the mine water treatment scheme. This will be the first large waste mine water heat project in Great Britain. It's led by Durham County Council in partnership with MRA, Vital Energy and Carbon Homes. And the low carbon heat network will provide waste heat to 750 affordable homes with significant spare capacity. A graphic to show the scheme's operation. Mine water is pumped from the shaft to surface, and on the non-aerated side is passed through the heat exchanger, the energy centre, so heat taken to the energy centre and the heat network. The cooled mine water is returned to the Dordon treatment scheme for chemical treatment and release to the sea. So the treatment scheme provides mine water at 20 degrees and is a pumped flow rate of 90 litres a second. That gives a thermal resource of in excess of 1.6 megawatts peak load, and will provide a guaranteed flow of 75 litres per second to the energy centre. The energy centre is run by Vital Energy, and they'll capture 5 degrees temperature from the mine water and utilise 2 heat pumps rated at 733 kilowatts each, in combination with 2 thermal storage tanks. Once the development is built out and the heat network completed, the total heat demand will be in the order of 4.7 million kilowatt hours per year. And from the carbon saving modelling that was done originally on a 25-year life, we can see carbon savings are estimated to be around 28,000 tonnes over that model life. We've signed a water access agreement with Durham County Council of plus 40 years, so we anticipate that carbon savings will be much closer to 50,000 tonnes at least over the life of the scheme. And the CM Garden Village project will now act as a demonstrator site, and we aim to install many more waste heat schemes across Great Britain. Looking now at the connection process and how to connect to a waste mine water heat scheme. I won't go through all the details, but those that are interested in the full process can review this from the recording. So when we receive an inquiry, we'll check to see if there's a suitable and functioning mine water treatment scheme nearby. If there is, we'll carry out an opportunity check and look for any critical constraints and what sort of heat scheme will be most suitable. If there isn't, and the development is above mine workings, we'll pass it to our heat advisory team to advise on borehole-based options for accessing mine water heat. So flowing through stakeholder engagement and the delivery of process guidance and timelines, the developer will supply mine water and operational data and review specific aspects of the scheme. We'll mention the responsibility for the scheme design and overall viability will sit with the developer. And as we work through the technical and financial viability, we'll end up with 2 main options for delivering mine water heat, waste mine water heat. If we're looking at a larger development with bigger heat loads, an energy center and heat network will have a desired timescale of something over 2 years from start to finish. If we're looking at small heat loads, well, an energy blade type system, something in the order of 12 months or less. On the final steps then for the energy center and heat network, once the head of terms agreement is signed, which specifies a guaranteed flow rate, and the developer completes design and procures the operator, the contracts are completed, we'll fit the connection valves to our treatment site and make any changes to abstraction and discharge consents. And as the final checks are completed and the scheme goes live, great. For the energy-based systems, which are much simpler and quicker to install, as the developer formalizes the design and appoints a contractor and the scheme moves forward, we'll negotiate a temporary construction license to allow the scheme to be constructed and commissioned. And during that process, we'll negotiate a long-term operational license and jointly carry out final checks for scheme operation. So finally, just a few words on the open access data for our mine water that we made available on our online viewer. I'll put the link at the top and you can search for MRA online viewer to find it. If you go to the mine water heat tab, there's all sorts of useful information on surface waste heat and subsurface heat. If you select the waste heat layer, the top, you can see the distribution of our mine water treatment centres across the UK and useful attributes for each of those, useful data around temperature, flow rate, salinity, and heat potential, for example. So in summary, I hope that I'm not just preaching to the converted and that there are industry people, local councils and others who are also on the call today. And hopefully I've been able to give some confidence that mine water waste heat schemes are in operation in the UK and indeed all around the world. And this is a call to action to local planning authorities and councils, those working on local plans or master plan developers, to get in touch with the MRA. There's a waste mine water heat scheme coming to you shortly. And as part of our drive to maximize uptake of waste mine water heat, we've installed temperature and flow monitoring at key mine water treatment schemes to aid heat network design, and we're providing offtakes to all new schemes. Looking into the future, we've started to think about and work with colleagues such as the BGS around underground thermal storage as a possibility to bridge any peak load demand gap and avoid alternative energy sources. Thank you, and hopefully there's time for a couple of questions.